Hey guys, today we are going to talk about and take notes on trigonometric functions with right triangles, how to solve them, and how to write different trigonometric functions, some old ones and some new ones as well. One thing I want to point out for this week is the homework is going to be 7.1 homework check on Canvas, as well as 3 Khan Academies. So you should now have a total of 21 Khan Academies. Just a heads up, this is going into the grade book next week. So if you have not gotten caught up on your Khan Academies, now would be a great time to start. So what I want you guys to do today for your warm-up is on a separate sheet of paper, go ahead and find the missing side length or angle of the given triangles. Pause this video. Once you have solved them out, or you think you have solved them out, go ahead and restart again to find the answer. All right, hopefully you have taken a few minutes to get this warm-up done. Now let's go ahead and look at the answers. First, I would recommend figuring out and labeling the different sides of your right triangle. So we can tell the hypotenuse is going to be the side opposite of the right angle. The rise is going to be opposite of the given angle, and in our first triangle, 41, our angle B is our given angle, so our rise is going to be opposite of that. And our run is going to be adjacent to that angle, so the leg that is directly touching the angle. In the first problem, we're trying to solve for the side length x. So we can see that we know what the rise is, and we're trying to find the hypotenuse. So sine is going to give us that rise over hypotenuse ratio. So we can set up sine of 41 equals 3.5 over x. We can cross multiply and then divide by sine of 41 to get x all by itself. Finally, we can use our calculator and get that x is 5.3. On our next problem, once again, we can set up and label the different sides of our triangle. So once again, the hypotenuse is the opposite of the right angle. And then we're going to locate where theta is. In this case, that's angle A. Our rise is going to be the side length that is directly opposite of theta. And our run is going to be the adjacent side, or the leg that is touching our angle theta. In this one, we're trying to solve for theta. We're trying to find that angle. So because we know the run and the hypotenuse, or the adjacent side and the hypotenuse, we can set up cosine of theta equals 6.9 over 12, so our run over hypotenuse. In order to undo the cosine, we're going to use inverse cosine. We can think of our inverse cosine as undoing. So just like a square root would undo a square, or a cube would undo a cubed root, inverse cosine undoes a cosine. So we'll take the inverse cosine of both sides, which will cancel out the cosine and leave us with theta. So theta equals the inverse cosine of 6.9 over 12. We can plug this into our calculator and get roughly 55 degrees. You should have a packet for Chapter 7. This entire packet will be used throughout the entirety of Chapter 7. We'll put all of our notes in here. It is 3-hole punch and stapled, so make sure when you are finished with today's lesson, put it somewhere safe so that you do not lose it. I recommend putting your name and class period on the front cover so that if it were to get lost, it can easily get returned. So now go ahead and turn to the very first page. This is what we'll be filling out for notes today. And we're really talking about right triangle trigonometry. So trigonometry is based upon ratios of the sides of right triangles. The ratio of sides and triangles with the same angles is consistent. The size of the triangle does not matter because the triangles are similar. So this is going to follow along with number 1 in your notes. We actually have 6 different trigonometric functions. You've already learned 3 of them last year, so we're going to be introducing 3 brand new ones, which is cotangent, secant, and cosecant, on top of the ones we already know, which is sine, cosine, and tangent. So sine we see as the opposite side over hypotenuse. In other words, it is our rise over the hypotenuse. Cosine is our adjacent side, or our run over the hypotenuse. Tangent is opposite over adjacent. In other words, our rise over run. You'll see the opposite and rise, as well as adjacent and run, interchangeably throughout this chapter. A lot of colleges will actually use the opposite and adjacent and hypotenuse over rise, run, and hypotenuse, but it truly is personal preference. So we can also label our cosecant, secant, and cotangent the same way. It is important to note, if you haven't already noted, that the sine and cosecant are reciprocals, so the fraction is just flipped. Cosine and secant are reciprocals, and tangent and cotangent are also reciprocals of one another. So the big question comes up is, what's the difference between an inverse versus a reciprocal in trig functions? Well, inverses are undoing the trig function. So the inverse cosine would undo the cosine function, whereas reciprocals are just the fraction flip-flopped. So we use inverses when we solve for angles a lot of the time. Reciprocals can also be seen as sine of theta is 1 over the cosecant of theta. So we're just looking at the reciprocal as 1 over the reciprocal function. So you guys do not need to write this down on your paper unless you would like to make a note of it. So now on to actual practice, and this is going to follow along with number 2. We're given two sides of a right triangle, and we want to find the 6 trigonometric functions. We want to find the value of those, otherwise known as the ratio of those. We don't actually need to solve for theta. We just want to be able to write the ratio of each of the functions. If we look at this triangle, we're given both the rise and the run, or the opposite and the adjacent, but we need to figure out the hypotenuse. This is a very well-known right triangle. It is a 3, 4, 5 right triangle, so we can go ahead and label the hypotenuse side as 5. If you didn't know it was one of the well-known right triangles, we can use Pythagorean theorem to solve for that hypotenuse. Now go ahead and pause the video. While your video is paused, I want you to see if you can write the 6 trigonometric functions given this triangle. Resume once you think you have found all the answers. Go ahead and double check your ratios are the exact same as mine. Once again, if you needed to before, we can go ahead and label your triangle. We have the hypotenuse. The side opposite our given angle is our rise, which is the opposite. And the side adjacent or touching our angle is going to be our run. All right, moving on to part 3, which is special right triangles. We should have seen a little bit of this in geometry. However, it is always good to kind of review and recover. So the first special right triangle we have is the 45, 45, 90 degree right triangle. So the first thing I want you to do is look at your triangle, the farthest one on the left on the sheet of paper, and go ahead and identify the 2 legs, label them X, and identify the hypotenuse, which is 2 times that leg value, which is X. In order to solve right triangles, we need to be able to figure out how we can move from one leg to the other. So if I know this value of X, it is just the same as our other leg, which makes the 45, 45, 90 degree triangle really nice. And if I know one of the legs, in order to get to the hypotenuse, all I have to do is multiply it by the square root of 2. Now on the other hand, if I know what the hypotenuse is, in order to figure out the leg, I just need to divide the hypotenuse by the square root of 2. So now practicing actually solving for this, I know what one leg is, so I know my other leg must be the same exact value. So B has to equal 9. And in order to get from my leg to my hypotenuse, I multiply that value by the square root of 2. So 9 times the square root of 2 is just going to give me 9 square roots of 2. Now we want to make sure to leave the answer in simplest radical form. So although we could get a decimal approximation of this, we want to leave it as is. Next, we'll look at the 30, 60, 90 degree triangle. So go ahead and take a second, figure out your side lengths, and go ahead and label them appropriately. So your hypotenuse will be labeled 2x. The shortest side, which is going to be the side across from the 30 degree angle, is going to be your single x. And then the longest leg, or the side across the 60 degree angle, is going to be square root of 3 times x. So once again, it's important to know if we're given a side length, how do we get to the other side lengths? So if we know what x is, or the shortest side length across from the 30 degree angle, all we have to do to find the hypotenuse is multiply it by 2. And all we have to do to find the longest leg is multiply it by the square root of 3. Now, if we were given the hypotenuse, the easiest way to figure out the rest of the sides is by dividing by 2 to find the shortest side length, which is x. And then from there, you could multiply that value by the square root of 3 to get the longest leg. If we were given the longest side length, in order to get back to that single x value, all we have to do is divide by the square root of 3. And then once you know that x value, it's easy to find all the other values of the different side lengths from there. So once we have this all labeled, let's go ahead and practice finding the rest of our side lengths. All right, so the only side length we know is the side length across from our 60 degree angle. On our notes, we said if we knew this side length, all we would have to do is divide by the square root of 3 in order to find our shortest leg. So we have 2 times the square root of 3 divided by the square root of 3, which is just going to leave us with 2. Now that we know the shortest side length, in order to find our hypotenuse, we just need to multiply this value by 2. So 2 times 2 will give us a value of 4. Finally, to fill out our table, we want to look at all of the different trigonometric functions with different angles of the given triangle in the video. First thing I would recommend is labeling all of your different sides with hypotenuse, rise, run, or if you choose opposite over adjacent. And then go ahead and figure out what the sine of that angle is. All you have to do is figure out what that ratio is. Go ahead and pause the video right now. Fill out your table for the very first row for 30 degrees, and then resume to double check your answers. Hopefully your table looks a little something like this. However, we have 2 minor issues with what we have written down in the table. And those minor issues stem from the fact that we have square roots left in the denominator of our fractions, and we don't want that. So we're going to do something called rationalizing the denominator. How we rationalize the denominator is we want to multiply this ratio by a giant 1 to get rid of that square root. So in this case, the square root we're trying to get rid of is the square root of 3. So our giant 1 that we're going to multiply by is going to be the square root of 3 times the square root of 3. And when we multiply fractions, we multiply straight across. So 1 times the square root of 3 is just going to leave us with the square root of 3. And the square root of 3 times the square root of 3 is going to give us the square root of 9. The nice thing with this, we can't simplify the square root of 3, but we can simplify the square root of 9, which is going to be 3. Now we have a nice ratio where there is no square root left in the denominator. We're going to do this same thing with the secant function. So our giant 1 we're going to multiply by is going to be the square root of 3 over the square root of 3, since we're trying to get rid of the square root of 3 in the denominator. We multiply straight across, which will give us 2 times the square root of 3. And then as we've seen before, the square root of 3 times the square root of 3 is just going to give us 3. Now we just want to double check that we can't simplify this any further, and we can't, so we are all good to go. For the second row in our table, we're going to look at a 45, 45, 90 degree triangle. And once again, we're going to find the sine, cosine, tangent, cotangent, secant, and cosecant using this triangle. Go ahead and pause your video while you do this. When you're finished, double check your answers. Go ahead and double check your answers from your table. And just be careful, in this case, sine of 45 degrees and cosine of 45 degrees, you'll need to rationalize the denominators. Finally, we're going to look at the same triangle we were looking at before for 30 degrees, except for now we're going to analyze the 60-degree angle. So we're going to go ahead and find all ratios for the 6 trigonometric functions of the 60-degree angle. Once again, go ahead and pause the video. See if you can solve these on your own, and then come back and double check the answers. All right, double check your answers to this problem. Remember, once you are finished, simplify as much as you can and simplify in radical form. So we need to rationalize the denominators, and if there's any reducing we can possibly do, we want to make sure we do that. Now that we are finished taking notes, go ahead and make sure you have a blue worksheet. So if you need to come grab that from the front of the room, please do so now. With this blue worksheet, there are a couple things that I want to point out. The first 4 questions, you guys are just rationalizing the denominator like we've been practicing. The next 8 questions, we are writing all 6 trig ratios for each given right triangle. So if you've noticed, I've kind of marked up this paper in the video, which you guys will need to copy down as well on your sheet of paper. So for number 5, 6, 7, and 8, I give you guys the angle to which you guys are solving, which is angle x. So what I would like you guys to find is the ratio for sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and finally cotangent of x. So we're going to find what all of those trig functions are equivalent to. We will do this for every single triangle on this front side of the paper. Now for problems 9, 10, 11, and 12, you do not need to solve for x. I have solved and written it down for you, so you can go ahead and copy that down. And you guys are just going to solve for the identified angle theta. Once again, I do not need to know what theta equals. I just need to know the trig ratio. So once again, do not solve for any angles on here. You're just setting up that ratio for all 6 functions. On the back side of this worksheet, you will find problems similar to the worksheet where you are identifying a missing side or missing angle, and where you're getting practice using the special right triangles. When you are finished with this worksheet, put it somewhere safe. We will be taking it out and looking at it next class. Thank you for watching the video.